Good morning, students. In previous lecture, we have seen that the application of Gauss laws. Now, today, we have to study electric potential, new article. We have to study new article, that is in the textbook, and number is 8.3. This article is of electric potential and potential energy. So we know that in nature, every body in nature, there is storage of energy. Every system in the universe, there is storage of energy. The question arises here, how much energy, how much potential energy stored in the body or in the system and in nature? To find the energy, potential energy stored in the system or in every body in nature, we must find the amount of work done against the opposing factor in that system. This amount of work done in case of this system is electrostatic system, so that we must find the amount of work done against the electrostatic force to achieve a certain configuration, to achieve a certain position of charges in the given system. Means to achieve the certain charges, certain configuration of charges in the given system, we have to perform some work against the electrostatic force to change the configuration of the system. This amount of work done to change the configuration of system, this work is stored as electrostatic potential energy in that system. So that how much work is required to change the configuration of a given system, we have to find dependence factor of change in potential energy in that system. So we know that by Coulomb's law in electrostatic, like charges repel each other, unlike charges attack each other with some force. But if we have to move any charge in the electric field of other charge, then we have to perform some work on this charge, on this movable charge against this electrostatic force between two charges. This work done against the electrostatic force to change the configuration of the system, to change the position of the system, that is for the collection of electric charges in a given system, we have to perform some work. This work is a measure of increasing potential energy, changing potential energy in that system. So this is the concept of potential energy. Potential energy is the amount of work done against the electrostatic force to achieve the configuration of charges in a given system. This work is a measure of electrostatic potential energy in that system. This work is a measure of changing potential energy of this system, and we have to find the dependence factor of change in potential energy of a given system. For this purpose, we consider a positive charge in the surrounding space. If we consider a static point charge, positive charge in the surrounding space, what happens? This static point charge in the surrounding space produces electric field in the surrounding medium. And if we bring any other charge in the electric field of this static charge, given charge, we have to perform some work on the charge. This work done by external agent against the electrostatic force between two charges is a measure of changing potential energy or increasing potential energy of the system. For this purpose, we consider the system of single point charge. That is, let us consider the point charge, positive point charge is situated at point O in the surrounding space. This positively charged plus Q at point O in the surrounding space produces electric field. In that electric field, we consider a point P is at certain distance, say R. Now, we have to find how much potential energy is stored at point P due to this Q charge, because Q charge, and this is the system of Q charge, produces electric field, and in that electric field there is storage of electrostatic potential energy. And for this purpose, we consider the point P is at distance R from the charge Q. Now what happens? This Q charge produces certain electric potential at point P. Now, to find this electric potential, to find the potential energy of a particular charge which is placed at point P, so that if we consider Q0 charge, when we place Q0 charge at point P in the electric field of the static positive charge Q, what happens? According to Coulomb, this positively charged Q at point O repels this Q0 charge and at point P with some force, so that Q0 charge at point P experiences a force of repulsion. F is the force experienced by Q0 charge due to plus Q charge, because we place this Q0 charge in the electric field of this plus Q charge. Naturally, this plus Q charge repels this Q0 charge at point P, so that Q0 charge at point P has a tendency to move away from the point P, away from the point P means along this direction. Now, if it means that this Q0 charge which is placed at point P is not free from this electric field, because Q0 charge at point P is bound to this force of repulsion. Now, in order to move q0 charge from point P to P dash through a very small distance dr. When q0 charge moves from P to P dash, actually q0 charge is bounded by this force. And this force has tendency to move this q0 charge away from the point in this direction. But we have to move this q0 charge from P to P dash through a very small distance dr. We have to apply external force is of same magnitude to that of this force, but opposite direction. It means that this applied external force is of same magnitude to that of this force of repulsion. Does some work, so that this q0 charge moves from P to P dash. So that this work done by this applied external force against this electrostatic force in moving the q0 charge from P to P dash through a very small distance dr is a measure of increasing potential energy, change in potential energy and of the system. And this change in potential energy is given by Bu is equal to Fe dot dr or is equal to minus Fe dot dr. The change in potential energy. Now clear this concept? You remember, very simple thing. This plus q be the charge we get at point O in the surrounding medium. Surrounding medium is suppose air. The in air medium we place this plus q charge at point O, so that this plus q charge produces electric field in the surrounding space. In that electric field, there is storage. There is storage of electrostatic potential energy and due to this q charge. Now in that electric field, we consider the point P is at distance r from the center of the charge q. And at point P, to find how much potential energy is stored at point P, and for this purpose, we take q0 charge at point P. Now, when we place q0 charge at point P in the electric field of the q charge, what happened? This q charge is more stronger than that of this q0 charge. So that this q charge, positively charged q, repel this positively charged q0 at point P with some force. So that this q0 charge at point P experiences a particular direction of force, and direction of force experienced by q0 charge at point P is always away from the point P and along this straight line. Because of this force, because of this electrostatic force, q0 charge had a tendency to move away from the point P. It means that this q0 charge at point P is not free from this force. And if we have to move this q0 charge from P to P dash through a very small distance dr, if I bring this q0 charge from any point in the electric field and of this q charge, what happens? This a field force of repulsion opposes and this displacement dr of the charge. But we have to move this q0 charge from P to P dash in this direction. So that we must remove this force by any means. If I remove this force of repulsion at point P along this direction by any means, then this q0 charge at point P will remain free and start moving from P to P dash in the electric field of this q charge. How we can remove? We have to apply external force having the same magnitude that of this force of repulsion. Then this q0 charge start moving from P to P dash through a very small distance dr. It means that this applied external force minus F does some work against this force of repulsion, so that q0 charge at point P moves from P to P dash. This work done by this external agent, by this applied external force against this force of repulsion in moving the q0 charge from P to P dash through a very small distance dr and is a measure of increasing potential energy. Increasing potential energy of the system and is given by du is equal to F8 dot dr. Get the, but this force and this is the applied force minus F into dr. So this and work done by this work done against the electrostatic force in bringing the q0 charge from one point to another point is a measure of increasing potential energy of the system and is given by d is equal to minus F into dr. Now this is the concept of change in potential energy or increasing potential energy of the system due to q charge. Now we have to obtain expression for potential energy of the system. Now clear this concept? I think it should be clear, and only you remember one thing. If we have to move any electric charge in the electric field of the other charge, then we must perform some work on the charge against the electrostatic force. This work done against the electrostatic force in moving a particular charge from one point to another point in the electric field of the system, in the electric field of the given charge. This work is a measure of increasing potential energy of the system. Due to this moment, there is increasing potential energy of the system, because previously every system there is storage of electrostatic potential energy, and how much potential energy stored in the given system, if we have to find, then we must perform some work against the opposing factor, in order to change the configuration of the system, in order to change the position of the system. This change in position or configuration of the system, the amount of work is required. This work done against the electrostatic force is a measure of increasing potential energy of the system. Now clear it is? Now we have to obtain expression for potential energy. To obtain the expression for potential energy of the system. To obtain the expression for potential energy of the system, we must find the amount of work done in moving a particular quantity of charge from one point to another point. We must find the amount of work done against the electrostatic force in moving a particular quantity of charge from one point to another point. This work done against the electrostatic force in moving the particular quantity of charge from one point to another point is a measure of change in electrostatic potential energy of the system. For this purpose, to obtain this expression for potential energy or to find the dependence factor of change in potential energy of the system, we must consider a point charge, positively charged plus Q, that is point charge plus Q is situated in the source. Positively charged plus Q we consider in the surrounding space at point O is the source of electric field. Let positively charged plus Q is placed in the surrounding space at point O. Naturally, this plus Q charge at point O produces electric field in the surrounding medium. Now, we have to find the change in potential energy of the system. For this purpose, if we move a particular quantity of charge from point A to B, let the Q0 charge be placed at point A and it moves from A to B. How much change in potential energy of the charge from A to B? This is our aim. When to find the change in potential energy of a given system, we must move a Q0 charge from A point to B point. The amount of work is required to move a Q0 charge from A point to B point. These 2 points are situated at distances R1 and R2 from the point Q charge. From A to B, we have to move Q0 quantity of charge so that some work is required without any doing work. Without any doing work, Q0 charge cannot be displaced, cannot move from A point to B point. In order to move Q0 quantity of charge from point A to point B, it requires some work. We have to perform some work on this charge against this force of repulsion. So that you imagine this for this purpose. For this purpose, we consider Q0 charge at point A. When we place Q0 charge at point A, in the electric field of the Q charge, this Q charge repel this Q0 charge at point A with some force, so that this Q0 charge experiences a force of repulsion away from the point A. But we have to move this Q0 charge through a very small distance dr. What we have to do? In order to move Q0 charge through a very small distance dr, we have to apply external force is of same magnitude that of this force but opposite direction. This applied external force does some work on this Q0 charge against this force of repulsion, then Q0 charge moves through a very small distance dr. This work done by Q0 charge in moving through a very small distance dr is given by, that is dw, means du is the increasing potential energy of this system, that is du is equal to F minus F into dr. Minus Ft in the textbook, and the symbol is used for electrostatic force. F represents electrostatic force. So this much, for the displacement dr, we have to move this Q0 charge through a very small distance dr. This applied external force minus Ft does some work against this force of repulsion is a measure of increasing potential energy or change in potential energy of this system, and the change in potential energy of the system is done by minus F into dr. Now